Alrighty, so hello and welcome. Howdy. Guten Abend, good day. So I think the plan for me is going to be I don't know, man. I don't know what the plan is. I just want to finish. I want to do the Java, Ruby, and JavaScript modules here on Hackerrank, and just spend some time doing those things. And then I think the plan for me, I got a couple of recruiters helping me out to find a job. I think the right thing to do is to try to look for a job and do that for a month until October, or the end of October, because it'll be November. So this is almost the end of September, so beginning of October. So like all of October, we'll spend like studying and looking for a job. And then depending on where we're at the end of October and November, I think what I'm going to do is I need to have a job. So at that point, I'll start looking a little bit more for like just something to be doing in the meanwhile, while I'm kind of figuring things out. And then probably want to learn how to drive a forklift, see if I can get a forklift job. I'll pretty much take anything at that point, more likely than not. And then get a forklift job potentially, because that pays better than like delivering pizzas. And then I think I want to get my CDL. I might actually literally just like quit software engineering at that point. Maybe not completely, but like maybe, I don't know. Because getting a CDL is kind of tricky. It's kind of involved. So I think I could do it without going to school, without CDL school. It's a bit ballsy, but I don't know, man. I'm kind of a smart guy. Maybe I could do it. We'll see. But yeah, I think the goal is going to be, I think I just want to get my CDL, and then if I can get a job as a software developer, that would be good. That's probably one of the better things, better outcomes. But obviously it's extremely challenging. It's such a pain in the neck. It's such a pain in the neck getting a job as a developer. Yeah, I don't know. But I think I'll give myself at least a month, and then after that, then I gotta like really get on like make sure I have a job, and then I gotta make some decisions about like, well, do I really want to keep trying to be a software developer for my future, or do I want to? Because I think if I get a CDL, what I'd want to have is probably have some money saved up in order to get a truck, get my own truck, and then work as an owner-operator. Yeah, I don't know. The tricky thing though with trucking is like you kind of need experience. So I don't know. I don't really know. I don't know what I want to do exactly. I mean, I could work for somebody for a few months and like help me get a CDL. I get paid pretty good money, and then have some experience, and then I can go get a truck and go from there. Yeah, but anyway, I don't know. Kind of just pondering different things. I have so many different options, so many things to think about, so many things going on. But yeah, so here we go, Java. Let's go. See how much time we can get in here, how much we can do. But yeah, I'm really annoyed. Just like life's been hard. Like I don't know what to say. Just like it's been a struggle. It's like really frustrating. And it's upsetting, and I don't do too well with failure, because it's just like, dude, how do you invest like so many years into something? The return is just very disappointing. Let's play a game on an array. You're standing at index 0 of an n-element array named game. From some index I, where 0 is less than or equal to I is less than n, you can perform one of the following moves. Move backward. If cell I-1 exists and contains a 0, you can walk back to cell I-1. Move forward. If cell I+1 contains a 0, you can walk to cell I+1. Cell I plus leap contains a 0, you can jump to a cell I plus leap. If you're standing in a cell n-1 or the value of I plus leap is greater than or equal to n, you can walk or jump off the end of the array and win the game. Okay, interesting. In other words, you can move from index I to index I+1, I-1, or I plus leap as long as the destination index is a cell containing a 0. And leap, Okay, if the destination is greater than negative n minus 1, you win the game. Okay. Okay. Is it? Can you do less than the leap if you're standing on? You can walk off. So it's 1, -1, or leap, right? Those are your 3 options. Okay, sure. Complete the can win function in the editor below. Has the following parameters: leap, size, and game, the rate to traverse. If the game can be 1, otherwise false. First line contains an integer q, denoting the number of queries. The function call is the 2 times q. Subsequent lines describe each query over 2 lines. The first line contains 2 space-separated integers describing the respective values of n and leap. Excuse me. The second line contains n space-separated binary integers, 0s and 1s, describing the respective values of game sub 0, game sub 1, to game sub n minus 1. 1 q 5000 to n 100, 0 leap 100. It is guaranteed that the value of game 0 is always 0. Value of game 0 is always 0. Okay. So let's see. Okay. Sample, but yes, yes, no, no. 4 queries. So I guess each game is another query, right? Game size n equals 5, leap equals 5, second query. I don't know why they'll just call these games, but okay. So yeah, so the first one you could start at 1, you could start at 0, and you could just hop 1 across all the way to the end. This game, if the leap is 5 and the size is 6, then you can hop 1 here, and plus 5 gives you, so if it's n minus 1, they're saying greater than or equal to n. Okay, so 0 indexed, I think. So meaning from wherever you are. Yeah, okay, yeah, 0 indexed. Okay, good. So we're on the same page. So 1 plus 5 gives you 6, and so then you can hop 1 forward and then hop off the edge. Oops, didn't mean to do that. Nope. Okay, I think we're okay. How are we doing on time? 8 minutes? Okay. So you hop 1 and then hop off the edge. And then 6 and 3, you can do hop 1 here, and then you have 1, 2, 3, it looks like, and you can hop there. So I actually don't know if it's possible to hop that far, because you can only excuse me. You can only hop I have a solution to this problem, by the way. I have an idea. I think I have a solution. You can only hop 3 at most. And so even though you hop here, this index would be 0, this is 1, this is 1, 2, 3, this would be the 4th. 0, 1, 0, 1, 2, 3, 4, 5. Right, it's index 5. Yeah, so you can't get to 5. You can only go 3, which would be 1, 2, 3. So you can hop here, but that's not far enough. And then finally, the last one, the hop is 1, and you can't go past 1, and so you get stuck here. So, pretty interesting question. I want to say there's probably like a dynamic programming solution where, excuse me, you can say at each index from right to left, you can say, can you win from that index? And then if you can reach an index that you can win from that index, then that's a winning index, right? And you can kind of label each index a winning or losing, and then if the initial index is a winning index, then it's a winning. Then you return yes. If the losing index, you return 0. So I think that's the way to do it. And basically you have three possibilities from your position to check. Basically, you pretty much just go backwards from that position. So you would say, can this position win? Yes or no, right? And you've got the three options to go forward, right? You can do the leap, you can jump one. You can first it has to be a 0, right? Otherwise it's automatically a false or a no. You have three options, right? You can go forward to win, 1, or you can go forward with a leap, or you can go backwards. And those are all three different checks that you make to see if that's a winning spot. And once you've checked that spot, then you're going to check all of the positions that you can reach from there. And actually, we're doing this inductively, so this should be well, if you can't reach anything from there, then you're just done, and everything else. So everything should be initialized as false, as no. And whatever you can reach, so you can go 1 backwards, you can reach. You can go 1 forwards and 3 forwards. Well, you can also go. It's the other way around. It's actually everything you can reach if you inverted the maneuvers. So you can go forward 1 if that hasn't been analyzed yet. You can go backwards 1 and see if that has been analyzed yet. Or you can actually leap backwards. So that's how we're going to move back through the array. Each of those different possibilities, if they haven't already been visited. And the way that you know they have been visited already would be you can sort of have a, well, I guess you got to be kind of careful. Because of how we're hopping around, it's a little bit tricky. So I think what we're going to want to do is, because we're going back and forth, so we do kind of actually have to set. You can have just like an array of booleans. I mean, that's probably the easiest thing to do. Just whether or not you've already visited the spot. Set the boolean. So the check you're going to do is going to be move forward 1, move backward 1, and move forward a leap. And in each of those cases, if the thing you're jumping to is a win, then this becomes labeled as a win. And then you're also going to proceed by so really this becomes like a graph algorithm, like a depth first search. It's actually kind of a depth first search question. I think that's correct. Yeah, it's a depth first search, really, ultimately is what it is. So actually you can even do from left to right then in that case, and basically just cascade. You just recursively cascade your sort of winning values upwards, and you just don't revisit any cells you've already visited. I want to say the tricky thing with that is, you just remove the cycles from the graph. Depth first search should be fine too. So it's even better to do it that way, I think. So let's do a depth first search. I prefer that. I mean, if we're going to perform a depth first search, by the way, you don't necessarily need, you can kind of terminate early. You don't necessarily need to save. The only array you really need would be an array of the booleans to know which indices you've already visited. And in that case, you just say, well, if any of these options return true. So you really just cascade true, and then if all of them none of them return true, you just return false, and that's it. And so you don't actually need to even keep track. You don't even have to keep track beyond just visiting each node. And that should give you linear time. So okay, so we have our game. We're gonna say now we're gonna use DFS. And we're also going to use something else, which is what do they call that? I actually want to use an inline function for my DFS. Yeah. I think we can do that. I think we can just interface inline, and we want how many parameters do we want to use for our inline function? We want, well, we're going to have the leap and the, actually you don't even need that. I mean, you can really just do a class and just say just inline, and we're going to call it apply. Does it work like this? Does this make sense? Can we do this? Can we have a recursive? Oh, I see. Yeah, you can. I think so. Yeah, I think so. It goes like this. So apply, and this function is going to basically be our. So what do we want to return? Boolean, and it's going to be apply, and we're going to say, or just function. It doesn't really need to be. And we're going to say inline f. The parameters we're going to give are going to be, obviously we need our leap, and we also need our game. I think that's all we really need. I don't think we necessarily need very much more than that. Excuse me. And we're going to say base case. We have also, it's going to be, so in our inline function, when we create this, we have private member or other members that we have access to. So we could say private Boolean of, excuse me, Boolean array, and we're going to call that visited is going to be equal to new have a function, so visited is new game size, something like this. So that's a kind of a question. Do I want this visited set to be, I don't know if I can access this visited set inside of this function, or if I need to make it private and construct it. It's kind of a good question. So we're going to say use DFS, and we're going to say Boolean. So this is kind of my first time tinkering with, I guess, what would be like an inline function, really an inner class that provides an inline function for Java, because Java doesn't really have inline functions, so I'm kind of tinkering to figure out how to do that exactly. So visited would be new Boolean array of game.length, and then we'll see, can we return game or visited of 0, right? Something like this. And then we can call our inline function, our inline class f equals new inline, and then we can f.function leap game f. Let's see what this does. Legal start of expression, private class inline. Okay. Interesting. Missing return statement. Oh, it compiles. Whoa. Whoa. Was not expecting that. Wow. Okay. Neat. Wow. Okay. So we don't need to do that. We're fine. Amazing. Raise.fill. Visited. False. I think they're initially false, but yeah, I don't think we actually need to do that. Oops. Whoa. Excuse me. Sorry about that. I have this tendency to copy paste things, and then I forget to uncopy those pasted things. Okay, so we have base case, right? So our base case is going to be base cases. If visited of, oh, we want to have a current position. Yeah, so you can have a state object too, usually, not usually, but you could. In a game, something like this, we really don't need very much there. We could just have a current position. That's effectively the state. This leap value, actually, we don't even really need it in here. It's kind of accessed. Well, the game and the leap are both accessed through the. They're both accessed through through the scope, through the enclosing scope. So we have access to these variables. So visited function current inline f base cases. So if visited current, then return visited current, or yeah, return. Oh, that's a good question. Are we memoizing the DFS? I think you returned false if you've already visited. Yeah, I think you returned false. That's kind of interesting. Yeah, because the idea is that if anything returns true, you return true, but everything else is going to return false by default. So if you've already visited that spot, then you return false. Yeah, I think that makes sense. That this is really just to prevent cycles. So then you say Boolean ret equals false. So 4, and this is the 3 possibilities. Explore each neighbor. Call it a neighbor. Possibility, really. Which possibility? So we would say we're going to call f function on, it could be current -1. So first we set visited current equal to true. So we're not going to have any cycles anymore. Explore each possibility. So we say f. So we say ret. Really, it's or equals. I don't know if this syntax will work, but we can try it. Or equals current -1 of f. Current +1, and then current plus leap. And we say if ret, then we're going to return true. Otherwise, really could put this at each step. Let's return false. Doesn't make that much of a difference to terminate early here. So Well, yeah, why not? It really doesn't. I actually think it's probably better to terminate early. So now we're gonna say if current plus 1, or actually really just current is greater than or equal to game.length, then return true. And that's it. That's pretty much it. That's the whole shindig. And you would say the inline function, create this f, run the function from 0, and actually that might just be it. Null pointer exception. Okay, where is that happening? Why is that happening? How much time we have here? 26 minutes. Okay. Test. Test 2. What is going on here? Alright, so we don't get to test 2. Excuse me. Interesting. Oh, you know what? Ah, let's see. That might have something to do with it. No. Uh-huh. What is going wrong? That is the question. Test and test 2, we don't get to test 3. I thought maybe this was the culprit. But why? Visited? Null pointer? How does that happen? Really? Now, this compiled before. Compiled and ran. It just didn't get a null point. No, that's unusual. Not what I was expecting. We visited .length. How about that? Length of our array. Index out of bounds exception. Oh. Look at that. 5. Okay. Huh. What? What is going on? Very confused here. I am very confused. So the error is here. It must be this. It's causing a null pointer exception. But why? Let's see. No. Oh. Oh. that makes a lot of sense. Aha, I got it. So because this is an array of Boolean objects rather than an array of Booleans, which by the way really should just be an array of Booleans, and we don't initialize with the things being false, because oh, I see, because the default object is actually a null object for that's an empty array of Boolean. Oh, that makes a lot of sense. Okay. It's kind of a subtle thing. Again, differences between C++ and Java, not JavaScript, just Java, is these wrappers and how they function, all these different things, how they function. I see. Okay, I was wondering. It's like, that did make a lot of sense. Now I get it. It was automatically going to be null if you didn't fill with false values for the Boolean. So there's true, false, and null. That's what your values could be. Now this is kind of interesting. It could just be visited.length. I mean, really is what it should be. Oh, and or that's another thing. Less than 0 could happen too. Forgot about that. Wrong answer. Yes, yes, yes. Yes, yes, no, no. Well, that's not correct. Oh, now there's one more issue here. If base cases, so this is right. There's one more base case here. These are kind of self-explanatory. Yet one more case is game. Right, I forgot the important part is game of current. If that is equal to a 1, then we return false. So handle backtracking cycles. Another base case. I believe that's the one. What do we have? Debug statements here. Forgot about these debug statements. Wow, this was really involved. Ended up being kind of challenging to get it to code it properly. Now I think this is linear time. I don't think it's doesn't. I don't think. Oh yeah, it does take linear space too because of the you know. The cycles, trying to remove the cycles. Constraints, so we have 5,000 queries. Oh, okay, it's between 2 and 100. All right, between 2 and 100. Well, that's 500,000. That's pretty big. Interesting. I guess we go for it. I don't know. Is this correct? Maybe. Hey, got there. Sweet. That wasn't too bad. A little bit over 30 minutes. Yeah, I mean, it would be over 30 minutes because of the, just how much, I want to say something like how much time it would take. Well, it's not really the time. It was more so just the, I mean, thinking it through took some time, but also programming this properly. This doesn't need to be a object anymore, by the way. Programming this properly was challenging because of the, it was kind of like, ran into a few things that are sort of Java specific related issues. But yeah, this is obviously efficient, so efficient enough. Pretty good. Yeah, here's the goes to operator again. I appreciate that they put the parsing code in there already. Grateful for that. There we go. Okay, let's go to the next one. Let's keep going. I think we said today we're trying to solve the rest of these problems effectively. 2 types of queries you can perform on a list: insert y at index x, delete the element at index x. Given a list L of n integers, perform q queries on the list. Once all queries are completed, print the modified list as a single line of space-separated integers. One more time. In this problem, we have two types of queries that you can perform on a list. Insert y at index x, delete the element at index x. Two types of queries you can perform on a list. Insert y at index x, delete the element at index x. Okay. Given a list L of n integers, perform Q queries on the list. Once all queries are completed, print the modified list as a single line of space-separated integers. Sorry, you have to forgive me for a moment. I'm thinking about some things, and I'm like, oh, some of these things are just so depressing. Some of the thoughts that I have are just like very dark and very sad, just painful. Just a lot of pain, a lot of pain. I'd say pain is probably the right expression. Oh, but what are you gonna do? Sometimes you experience tremendous pain. Like I don't know what to tell you. Given a list L of n integers, perform Q queries on the list. Given a list L of n integers, perform Q queries on the list. Once all queries are completed, print the modified list as a single line of space-separated integers. So we could design our own list, but I think we're just going to use the list class. So, first line contains integer n, the initial number of elements in L. First line contains an integer n, the initial number of elements in L. Integer n, initial number of elements in L. The second line contains n space-separated integers describing L. The second line contains n space-separated integers describing L. Contains integer n. Okay, next line. Third line contains integer q, the number of queries. The 2k subsequent lines describe the queries, and each query is described over 2 lines. The first line of a query contains a string insert, then the second line contains 2 space-separated integers x and y, and value y must be inserted, into L at index x. If the first line of a query contains the string delete, then the second line contains index x, whose element must be deleted from L. If the first line of a query contains the string delete, then the second line contains the index x, whose element must be deleted from L. 1 less 3 equal to n less 3 equal to 4000, 1 less 3 equal to q, less 3 equal to 4000. Each element is is a 32-bit integer. Print the updated list L as a single line of space-separated integers. Print the updated list L as a single line of space-separated integers. Dude, I'm so annoyed. I'm sorry. I'm just thinking about things like that is just infuriating. Some of the things that have happened, the things that have occurred. Like, man. Sadness, difficulty, frustration, and pain. And pain. Just lots and lots of pain. Boy. Yeah, an incredible amount of pain. Just pain, 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 pain. Each element in is a 32-bit integer. Okay. Print the updated list L as a single line of space-separated integers. So I think we're going to just use a list object, list class, and perform all these queries. They want us to parse. All right, sure. Sure. Scanner, system in, and then we want to say, all right, so we have our format here. First line is integer n, Initial number of elements in L. Int n is going to be sc.nextInt. The next is n space separate integers describing L for int I equals 0, I is less than n. I sc.nextInt. Now, what are we going to do with that though? Do we want to put that into a list? And there's insert and delete. Okay, that's fine. I mean, we could just use an array list, right? Integers. Let's call it array. Excuse me. Now, this is something that was kind of interesting to me, where I job array list. I think this does have the list. What's interesting is that I think you do have the list operations. Just the thing that's interesting about it, or tricky about it, or unusual about it, is that even though you have the list operations, it's still an array, which is strange to me. So I don't really know how that works. I don't think I fully understand. All the other operations are linear. Okay, but the add is amortized constant. Get set is empty size iterator and list iterator is constant. So constant factor is lower compared to yeah. So there's array list and there's got to be a linked list. See, that's the thing. I think we want to go to abstract list, and then is there? Well, there are lists. Array list, linked list. Let's try that. These are okay. These are very different. So I don't know why array list is a list at all. I don't understand, but whatever. That's how they built the Java interface. So double linked lists. That's what we want. Yeah. So we should be able to add, and we should also be able to get. Really, what we're looking for though is remove. Yeah. Remove at the index and add an index. Right, that's what they said. They said excuse me. Insert at a position, then delete from a position. Now, what's interesting about this though is 4,000 numbers and 4,000 queries. I think each insertion and deletion actually is also linear anyway, believe it or not, which is a little bit weird. Yeah. Which is kind of pointless if, like, actually what you're better off doing is this actually isn't good. Because it doesn't matter, right? If you insert or delete at a particular index, you still have to traverse the whole list to get to that index. So it's still linear time if you do it that way. You can have, like, if you use a custom linked list, you can access elements in that linked list. Basically using a hash map. So no, actually, I don't know if you can even do that either. I don't know, man. This is actually kind of a hard problem. This question is not like an easy problem. Inserting and deleting elements at arbitrary points in a data structure is not a trivial thing at all in an ordered data structure, because excuse me, because when you insert, you shift all the other elements down, which is fine, but the deletion, same thing. You shift everything down depending when you insert, and when you delete, same thing. Everything kind of gets shifted again. But the problem is that even though the insertion and the deletion itself at a particular point is constant time, traversing to that particular point is not constant time, and you need to do that anyway in order to insert or delete. So that's kind of a tricky thing. Yeah, it's very interesting. Is there a way to do this more efficiently? No, I don't think so. From a data structure standpoint, not really. Not really. You can introduce logarithmic terms and use a tree and insert an element into the tree. But the problem with inserting an element into the tree is that it doesn't necessarily, well, I guess you can order the tree by these indices, but even that, you'd have to update all the indices to the right of a particular value. I think that's what we were looking at before. We were looking at a tree that that we maintain the order as we insert elements. Basically, this is the problem we wanted to solve. I wanted to write a tree that solves this problem such that the insertions are logarithmic time and the deletions are logarithmic time for all arbitrary insertions and deletions. And I think there is such a data structure that exists. That's kind of what I was trying to build the other day. I think you can do that using a tree. It's somewhat complicated. Basically, you just rebalance your tree, and you would, the indices basically are derived, when you're searching through your tree, is sort of a derived value from the total number of nodes in the tree and the number of nodes in like the subtrees, I guess. So each node would keep track of how many nodes are underneath it in the subtree, so you'd be able to quickly find a node at a particular index, even though each node doesn't necessarily, every node would know all of the, when you delete a node, you would update all of the parents, the number of nodes in that subtree, and you can use those numbers to track down indices. Each node would have an index based off of that value, and so you can delete those nodes, and then you'd also have, when you want to insert, you also update all the parent indices, and you can insert in logarithmic time using tree, like basically a red-black tree or an AVL tree. What do they call it? Tree rotations. You can use tree rotations to maintain height balance on the tree to keep it logarithmic to insert. And then deletion is also same thing. Those rotations you can perform after you perform a deletion or an insertion, and then obviously you need to make sure the invariant is maintained through the rotation. So after your rotations, you want to make sure that the nodes they all update to the correct number of elements in the subtree, which I think you can probably do that relatively easily with your rotations. You can just recalculate all the different nodes that moved around, recalculate all of their values. And so there you go. You can actually perform insertions and deletions in in an indexed tree, and do that in logarithmic time for those insertions and deletions. That's all well and good, however, that's not what we're doing here. For some reason, yeah, I guess we'll just have an array list then. It doesn't really matter if it's a list or array list. Linked list, array list, same runtime. Problem though is that 4,000 by 4,000 is kind of expensive in terms of complexity. Ooh, excuse me. I don't know, this might be too expensive. Well, we'll try it. We'll go for it. So yeah, so we'll create our array list initially, and then we'll go from there. So array.add our next int, and then we want to, each query is how many? There's going to be q queries. Q, yeah. Int q equals sc.nextInt, and then we can say for int I equals 0, I is less than 2 times q, plus I. We're going to, actually better than that would just be I less than q. Just do it that way. And then we're going to say int or string is next string s equals sc.next. If s equals insert, we're going to do the following. Else if s equals delete, we're going to say int a equals sc.next int, and that's going to be, there's going to be two of them, a and b. And then we also have, we can call a down here. And then we can say array.insert, and then I guess AB, and then this is array.remove, excuse me, A, and finally we just print, and then what does the printing say? We may have to modify this, I think that's not exactly the syntax. And as a single line of space separated integers. Okay. So we're going to say for 0 I is less than array.length plus I system.print, say space plus string, not of I, but array of I, and we say if I is not equal to 0, then we also print a new. Actually, I think I did it the wrong way. Okay, so you print the number, and then if we're not 0, so actually it should be the other way around. Before we print the number, we're going to print a space, except for when we're equal to 0, we don't print a space. So if we're not equal to 0, we'll print a space beforehand. Something like this. Syntax errors here. Okay. We need to find, so it's Java list. Let's take a look. add index element. Index element, so that's fine. And then the other one is remove. Should be remove, yeah, remove index. That's it. That's it. Okay. Oh. Sorry, what? Array.insert AB, it's right here. What do you mean you cannot find the symbol? Insert, oh. Integer, gotcha. That's fine. Huh. Very interesting. Very interesting indeed. So, one issue is this. This is apparently wrong. Why is this wrong? Oh wow, I see. It's the index and the element. I think the index comes second, and the element. So that's kind of interesting. So you have something like this. Oh, no, it's the other way around. Index and then element. Very strange. Oh man, come on. What is wrong? Oh, it's in. Oh, no. We're fine. We were fine. I messed up. No, we were okay. I was wondering. This doesn't make sense. It's add. It's not insert. It's add. That's why. I looked at it. I don't know how many times I looked at it, and I thought, huh, that's weird. I thought it was okay here. Int and integer wrappers can, for the most part, be used interchangeably in a lot of contexts. I think all the contexts. So I was very confused as to why I was getting that error. All right, let's go for it. See how we do. Okay, simple enough. I think that was the idea from the beginning. Simple. Simple. Okay, you know, all right, sure. How much time we have here? Probably go for another couple hours or something. I'm already kind of tired though. Well, I was tired from the beginning. I was tired this morning. I wanted to just sleep. So disappointed. Excuse me. Okay, you're given a phone book consists of people's names and their phone number. After that, you will be given some person's name as a query. For each query, print the phone number of that person. Given a phone book that consists of people's names and their phone number. After that, you will be given some name as a query of each query. Oh, I see. So we're using a hash map now. Yeah, got it. First line will have an integer n denoting the number of entries in the phone book. Each entry consists of 2 lines, a name and the corresponding phone number. After these, there will be some queries. Each query will contain a person's name. Read the queries until end of file. Constraints: a person's name consists of only lowercase English letters, and it may be in the format first name, last name, or in the format first name. Each phone number has exactly 8 digits without any leading zeros. So n is between 1 and, it looks like 100,000, and then queries between 1 and 100,000, 100,000 queries, 100,000 names and phone numbers. For each case, print not found if the person has no entry in the phone book, otherwise print the person's name and phone number, see sample output for the exact format. To make the problem easier, we provided a portion of the code in the editor. You can either complete that code or write completely on your own. For each case, print not found if the person has no entry in the phone book, otherwise print the person's name and phone number, see sample output for the exact format. For each case, print not found if the person has no entry in the phone book, otherwise print the person's name and phone number, see sample output for the exact format. Output format. For each case, print not found. Otherwise, print the person's name and phone number, see sample output for the exact format. Otherwise, print the person's name and phone number. Sorry, I have these thoughts, man. They're just like, they're so difficult. Dude, life's hard. Life is hard, I have to say. have to like rephrase that. It's like, no, life's not hard. Life's hard for you. Although I've been watching a lot of videos about people whose lives are significantly harder than mine, I would say. They seem to be just like, they're hellbound, basically, on the way to hell, their way to hell, and that's kind of it. God's letting them go. I mean, that's, you know. Okay, if the person has no entry in the phone book, print not found if the person has no entry in the phone book. Otherwise, print the person's name and phone number, see the sample output for the exact format. To make the problem easier, we provided a portion of the code in the editor. You can either complete that code or completely write completely on your own. Sure. So we have sample input, name, number, name, number, name, number, name, name, name. Oh. Okay. Uncle Sam not found. Harry. Tom. Okay. Sure. I think I get it. So for each string, we want to print looks like it's S plus equal sign plus, and then we'll use our hash map. And we'll say if, and there's a hash map somewhere around here. Put it all the way at the top. Hash map of, we want to go, call it H. And we want to say, oops. We want to say from string to integer. Hash map of string to integer. And all these already have hash functions, so we don't need to modify that at all. And we're going to say h.insert, and or we could just do h of the name equals, I think this format works, right? Does this work? Can we do this? Compilation error. What part is not compiling? String cannot be converted to int. What? Sorry. What's going on? Do we have an example of what's going on here? I think you do need to do put. I think is what you need. Otherwise, it doesn't make sense. Also, hash map Java 7. There's get, contains, and put. Yeah, okay. Key value put, sure. And we would say if h dot contains this key s, and then if not, really we want to do, well, yeah. Actually, we do, whoops. Okay, so if H contains S, then you S and you want H dot get S, right? Otherwise, not found. I don't want, yeah. They don't want any periods between the lines. Contains key. Oh, okay, that's interesting. So, oh, that's an Arraylist though. I'm wondering if version 8 and version 7 are different in terms of, oh, okay, that worked, okay. Are different in terms of what their function names are. Contains key, no, it still contains key. Contains key. Okay. Let's see if that's what they wanted. If I made a mistake. All right, very nice. Very good, very good. And I already just want to stop and take a nap. Just so tired. I don't know, man. I've been so frustrated lately. There's so many things I'm annoyed by and annoyed about. I don't want to go over all of that and go in too far into that, but yeah, life can be frustrating and difficult sometimes. I'll just say I'm extremely lucky, but oh boy, am I annoyed. String containing only parentheses is balanced if the following is true. 1, if, excuse me, it is an empty string. 2, if A and B are correct, A, B is correct. 3, if A is correct, A and A are also correct. Excuse me. String containing only parentheses is balanced if the following is true. If it's an empty string, A and B are correct, A, B is correct. Oh, okay, I see. Concatenation of the two strings are correct. And 3, if A is correct, then A enclosed in parentheses is correct. Curly braces, parentheses, and brackets are also correct. Some examples, and these are unbalanced. Okay. Oh yeah. Yeah, this is a classic problem. I've seen this. I actually have seen this in interviews. So this one you can use a stack. Oh man, if only I had performed the Hackerrank challenges on Java before I interviewed for that Java position, I would have aced it, man. It would have been no problem. That's so annoying. It's literally one of the problems on the site. It's such an easy one too. This is super easy. Ready? This is how you do it. Ready for this? So we scan. This is actually just the string. We'll have a private function we'll write. Actually, we could write our own inline function here, but we're not going to. We're going to say private. Just check. Private boolean check. Check. What do they call it? It's braces, curlies, and brackets. So it's a check format. That's what we want. It's really a format. And we have a string s. Arg-h. Interesting. You see that? Args. S. That's fine. We're going to say, okay. So really, we actually could just system.print line .out.print line check format. And again, we can go so far as to create this as an inline function, but I don't want to do that. I think it's not always worth the effort. Okay. So first we're going to have a character array. C. S.2. Actually, you don't even need to do that really. Well, I guess you do. Yeah, I guess you do. So you could do for character C in S.2 character array. Hopefully that's the right Java character array. I don't know. Alrighty. 2-character array, yeah, that's how you spell it. 2-character array, and we're going to say if we have a stack also, stack of characters, st, we'll call it new stack of characters. We say if, so first things first, so if C is equal to the opening brace, or C is equal to, I'm going to say dot equals, I think. Yeah, actually I think this is fine. So we can actually use this. We could do it this way. I think this is better. With the dot equals, keep it consistent. So it could be one of the opening, closing braces, really what we want, or opening brace. So you really have like a switch statement. Let's do it that way. It's probably better. Case is closing brace, opening brace, and yeah, there's like we could probably use a the default. Okay, so we could probably use a hash map somewhere in here also instead of using a switch statement. We just need to connect, basically have a way to connect each of the opening and closing curlies, parentheses, and brackets, but a switch statement works fine too. So we would say if we can get all the way through, we return true. If we can't, we return false. So we're going to push any character that's not a closing bracket, brace, or parentheses. We're going to push that character onto the stacks, st push, just real simple push C. Otherwise we say if st is empty, that's how you do it in Java, then return false. And actually you don't return true immediately, you say if return st is empty. If it's empty, return true, otherwise it's false. So if it's empty, return false, otherwise, or we want the top of the stack, so we can peek the the top of the stack, and we say if we peek, we're going to say we're going to say st peek dot equals and it's not equal to us. If it's any character other than the closing brace or an opening brace on top, then that means return false. And here we can say remove pop is what we want from the top. Can we pop? Java stack. Yeah, I would have had to look this one up. That's kind of what I thought. Yeah, it's just pop, peek, pop. Okay, just pop. Okay, fair enough. So if it's not empty and it's equal to this, then we would pop that. And that's really it. And just copy that 3 times. Like I said, you can kind of clean this code up a bit because you can associate, like this is kind of duplicated code. It's sort of the same thing each time, except the only thing that's changing is, excuse me, these characters. So you can kind of make like a hash map between these. I wonder if you can do that. You can just say like simple hash map, character to character equals something like this, where you would say like this character, opening brace, closing brace, and then opening bracket, closing bracket, and then opening parentheses, closing parentheses. I wonder, what does this do? First off, doesn't compile. Error, not a statement. Oh, we would need just like map, we'll call it, or m even. Need that variable needs a name. I mean, we can create it and then illegal initializer. How do can we initialize hash map Java? I don't remember how you initialize initialize a hash map in Java, and then initialize an array in Java as well. Map of. Initializer in an anonymous subclass to make the syntax a little bit shorter. Oh, okay, whatever. Not really that big of a deal. You can actually just do this, I think it'll work. But these you want to add, so you would say just put m.put and do each of these. And then you can say run that. Does that compile? No. I missed that too. Wrong answer. Nice. False all the way across the board. True in some cases. False in one spot. Why though? Huh. If you try to pop something that's empty, or you're popping something else off the top, oh, that's why. Right, I kind of stopped halfway through it to see if I can change things with a map. Still wrong. Really? Oh, it is wrong. No kidding. How do we do? Still wrong. Why? I actually think this should be correct at this point, but what's wrong though if it's not correct? So for each character in this character array of this string, we say if it's any of the opening brackets, or yeah, the opening characters, then we push those onto the stack. And then once we see a closing character, we check if our stack has anything. If our stack is empty, then we're not correctly formatted and return false. If it's not empty, then we need to see that the top of the stack is the corresponding character to remove. So closing curly braces, opening curly braces, closing parentheses, opening parentheses, and then closing. Oh, you know, that's why you need to break, because we end up pushing these characters onto the stack later. So we always end up returning false because the stack always has something in it. Okay, gotcha. Alright, that's what I was wrong. I missed the breaks. But you don't need those either. You can do, really you don't even need the switch statement. So actually let's submit it, see if we get it. See, this is a pretty easy question. Really, I was very lucky to get this in that interview when I got it, but like, still, I didn't have, like I said, I didn't have the syntax all together. All right, so we say if m is an opening character, so it's a m.contains key of C, then we would say push the character. So if it doesn't contain that, actually it's the other way around. It would go from the closing to opening. That's what we should have. That's what we want. Now, we can make an assumption about the input also, or we're kind of making an assumption about the input. We can make an assumption that we're only going to have these 6 characters, assuming that's the case. So then we would say, if we don't contain this key, or we do contain this key, we're going to do something. We don't contain the key, and then we're going to push this character. We assume it's opening. If it's closing, then we're going to say, then we're going to use this code here and pop. So we're going to use m.get. Actually, we could just m.get right here. And it's going to be C. So, yeah. So, if our stack is empty, or the top of our stack is not equal to the corresponding opening bracket, or opening character, then we return false, right? Because that means that we don't have enough characters in there, enough opening characters. We have too many closing characters, not enough open characters, or we have a mismatch between the opening and closing characters. And so we don't return false, so we pop that character because it's the right one. And that's really it. And then otherwise we have excuse me. And then we return whether or not our stack is empty at the end. Yeah, I've seen, like I said, I've seen this question quite a few times now. This is an easier version. This is a harder version of this. But this is the easier version. This is, in my opinion, better. Not better, but just it's just cleaner. It's simpler and easier to kind of work through. So yeah, this would be the solution I would probably would have wanted to write in my interview. But obviously I kind of need to remember how to write the hash map correctly and initialize it, and this 2-character array I would have to memorize, and have to make sure I got the peek commands, the hash map commands, and yeah, so and the stack commands too, and the methods, pushing and popping, and also the assumption that these are the only characters you have as well. Yeah. You could add some extra code if you really wanted to make sure it's only those characters that matter. Yeah, pretty interesting. Okay. I do really want to take a nap though. So we have, how many more problems? 16? Yeah, 16. So this is a heap. Like I said, I really dislike the name priority queue. I think heap is better. Just call it a heap. I don't know, I kind of want to take a break. Question is, do we classes, priorities? Java has a built-in priority queue. Fair enough. Priority heap, yeah. So you have add, clear, comparator, contains offer. That's interesting. Not insert, but offer. To array, remove, poll, peek. So poll and offer, interesting. So iterator contains add element. So there's add, remove, poll, peek, offer. Same thing as add. Clear contains, so add, remove. Okay. And there is empty somewhere around here, right? Yeah. All right. So you just have add. You still have add, remove is empty, and some other functions, but the basic ones is just add and remove. Fair enough. So you just add everything into the priority queue, and then now what I'm wondering is actually priority queues. You can build them by like adding all the elements in one shot. Should only take linear time to build. Implementation provides log n time for the enqueuing and dequeuing methods. Linear time for the remove. Oh, really? No kidding. It contains methods and constant time for the retrieval. Yeah, it doesn't have a way to build though, does it? Optional methods. Not guaranteed. Order traversal. Arrays.sort. Unbounded. It's interesting that you actually can't build the heap in Java using this class. It's kind of annoying. Java build heap. Linear time. Yeah, it should be nlog n time actually. $4,000 hours. Oh man, dude, 4,000 hours is a lot. Dude, that's a lot of hours. You'd have to do, if you do a 40-hour work week, that's 100 weeks, my dude. Oh man. Yeah, that's 2 years full time. That is really a lot. I mean, I've kind of probably spent like roughly that much time. I've already spent like I've spent like 8 years or something now practicing. So you really don't need that much time though. It's not that hard. Really not that hard, in my opinion. It does take a lot of time, but not that much time. It's maybe like 1 or 2,000 more like, which is maybe not even that much either, by the way. Like once you really get going, it really doesn't take that much time to go through all these problems. I think one of the things that I'm really lacking though is I'm lacking in practicing on-site interviews or like system design questions or like questions where you're coding with the other person, but like it's a very open-ended question. It's not really an algorithms question, but it's just kind of like a kind of a vague, broad design type question. That I kind of struggle with quite a bit. Yeah, it's pretty tough. So okay, so for the most part, I think in those situations you really just want to code something. Quite frankly, like you're better off just putting something down, because they seem to grade you based off like whatever code you wrote, and then you just need something that approximates a solution, and then optimize it from there. I think that's the best way to do it. Just don't get too high-minded, I guess, or too worked up about what you're thinking about, because normally when I program something, I take a lot of time to just think about it first, try to optimize it, and try to come up with like a good, like I don't want to waste my time by like being required to go back and reprogram what I wrote because it was just so poorly designed and implemented. However, I think a lot of companies don't really care for that. They're just kind of like, hey, you have an hour to code something, like go code something. We don't care if it's garbage, really. We prefer you just have something there, because it's going to be garbage if you only have an hour to code it, obviously. Like it's not enough time to even really think about the problem you're dealing with. Anyway, how are we doing? So, okay, so do we want to program this? I was thinking to just not do that. Oh, yeah. What I wanted to do is figure out how to build the heap in linear time. So I don't think you can in Java without building your own heap implementation. Yeah, it's like the bottom line, I think, here. That's kind of what I was looking for. All right, fair enough. So I do kind of want to just take a break, maybe take a nap or something, come back in like an hour, or come back in 30 minutes. I guess just take a break. Maybe we can just program this too. I mean, can't be that hard, right? I forgot what I even wanted to do. There's something I wanted to do. Number of students in a school who wait to be served. 2 types of events, enter and served, can take place, which are described below. Enter a student with some priority enters the queue to be served. Served, the student with the highest priority is served, removed from the queue. Unique ID is assigned to each student entering the queue. The queue serves the students based on the following criteria, priority criteria. Student having the highest cumulative GPA is served first. Any students having the same cumulative GPA, CGPA, will be served by name in ascending case-sensitive alphabetical order. Any students having the same CGPA and name will be served in ascending order of the ID. So I think, does this have like, how does this work? You got to give it a comparator, right? Yeah. Initial capacity that orders its elements according to the specified comparator. Yeah, I think that's it. Is there a way to set the comparator? Interesting. Question mark super E. I don't. The syntax is also very confusing to me. So we can use an anonymous comparator class object, and then and get our priority set up this way. So it's these different elements to set that up. And then we have create the two classes. Student should implement constructor, get ID, get name. Oh, so here there's like a similar problem where it didn't ask you to create this class. You don't really need this class, do you? I mean, does it matter? Oh, okay, I guess you do. That's kind of annoying. Okay, so I guess you do have to create these classes then. Sure, alright, fine. And then apply two classes. Student should implement constructor, methods, getters and setters, or actually just getters. Constructor, getters, method list student, get students to process all the given events and return all the students yet to be served in the priority order. What? Implement the method get students. So it's actually not necessarily, you don't necessarily need to use a heap queue to do this. You could actually just use if you're pushing them all into the queue and then popping them all out at the same time, or processing them all at the same time, then you actually only need, in that case, you actually can just sort. Like, you don't even need to use a priority queue, believe it or not. This is like a really bad example. It's kind of a really bad example, as it turns out. Total events, list, events, each event, add a new event. Priorities get students from the events. This just parses the students out of the events. And then it's empty, otherwise for each student print the name. I guess it's supposed to return the priority queue of the students, maybe? I mean, again, you can just return a sorted list. It doesn't need to be a priority queue. This actually isn't a list, by the way. So I don't know what is going on here. It's kind of annoying. This is kind of annoying. So we don't actually need to use the driver priority queue to do this, which is often the case, by the way. You typically don't need to use a priority queue to solve problems. It's kind of a rare use case, but it does have its sort of situations. Yeah, man, you can just use a sorting. You can just sort an array list. Okay. So in priorities class as one function that. All right, that's fine. Kind of, I guess we'll just code this up and then take a break. I guess we'll do it that way. That's fine. Sure. Student. And that's going to have a few things. Student, get ID, get name, get CGPA. Really don't need those things either, I think. Just from the interface they gave us in terms of what this is actually going to do. As long as you return this properly, it really doesn't matter. Only the get name, I think, is the one you really need. But potentially, right? Because you can make these members Well, whatever. Whatever, it's fine. We'll do it. We'll do it as they ask, because you could potentially also, excuse me, yelling in the mic here. You could potentially make these values public and access them directly instead of using the getters, but what's the point of doing that? Private int ID, private double CGPA, private string name, and then we just set these each. This.id equals ID, this.name, this.string CGPA, CGPA, and then we have our getters. So we return an int, public int get ID, return ID, get name, C GPA. I think we're using that camel case there. I don't think they call CGPA anywhere here, so it really doesn't matter. Okay. And so we have our student, and then we have the other one is priorities, class T's, and we're going to say, really it's a static function, I think. Get students events, so priorities, get students. Actually, it doesn't have to be static. Wait, they're calling it. In a lot of ways, though, it is a static. I mean, it's just really just a class that wraps a function. It's a list of students. Get students. It's going to be like the following. We have an array of strings. It seems to be, or a list of strings. Yeah. Priorities get students events. Yeah, okay, so list of strings. Events or students, or yeah, students we'll say, or just S. LS, I don't know. We'll call it array or list even. I don't know if I really like, yeah, it's fine, that's okay. So now we're going to have an array list of students, or list of students. Or ret, we'll call it, new array list students. And we're going to say for each string S in list, we're going to parse this string. This is its enter. Oh, excuse me. Oh, I take that back. Never mind. I misunderstood. Okay. All right. Okay. I get it. I get it. So we are going to use a priority queue for this. Okay. I take it back. Excuse me. All right. I understand now. I get it. I get it. So we're going to get a queue, we'll call it, or heap, really. And this is going to be just priority queue of students. Queue of students, queue. New priority queue. And we are going to get our comparator in here. And the initial capacity really doesn't matter as much as the comparator. That's really what we want to. So we can just say, initial capacity of 10, and then however our custom comparator here, we'll write that shortly, and then we could do. We could just. Yeah, we could do something like this. So And we're just going to say, I don't know, a comparator, by the way, has a comparator. So it's a comparator object we're going to initialize as an anonymous class that implements this interface. And we're going to go ahead and the comparator only needs to compare, I think. By the way, we're working on 7. Compare is all you need. Equals should be, we don't need to actually implement. Just all I have to do is implement compare. Which is a Boolean. Oh, it's an integer, right? It's a 3-way comparison. Compare, which is a 3-way comparison of, and our comparator is going to be between students, by the way. So student A and student B. And we're going to say, we're going to have our comparisons between A and B according to these rules. And then we can say for each string, we have a scanner C equals new scanner string, and we can say string operation is sc.next, and then we have 3 more variables, another name, GPA, and ID. So name, GPA, CGPA. I don't know if it's the next float, and then ID. Let's see. And scanner next float. Let's see. Scanner. Float? Yes. That's what we want. Is there a next double maybe? No, double. Double. Yeah, there you go. That's what we want. Next double. Oh man. Yes. Instead of next float. Alrighty. Now we say that's really if it's enter. We want to do that. If it's served, then we pop. Excuse me. So if op dot equals enter, then we can perform the rest of these routines. Else if op dot equals served. So here we're going to create a student, student, new student. New student. We could just call it yeah. Health student. Call it ST. Do it that way. How about that? New student of name, CGPA, and ID. And we said we would take the constructor ID, name, CGPA. So ID, name, CGPA. ID, name, CGPA. Okay, great. So student, and we want to say our Q dot add ST. We'll have our comparator that we didn't write yet. We're going to write that comparison function shortly. And then served, we say Q dot remove st. And presumably we're not. This isn't going to be incorrect in the sense that we're not going to serve more people than we enter. No students. Code prints empty. Okay. And then at the end of this, so we initialize priority queue. Priority queue. Custom comparator. Don't really need to. I mean, that's obvious, right? Here we just say parse and process line from the input. Right, it's kind of self-explanatory what those things do, and then return at the end. So we just say for. So actually, we're going to say a while. It's going to be queue dot not is empty. I'm going to say student queue dot remove, and we're going to say. So now, I don't know if this is the right order. What the students that are left, basically we're going to pop everything in the stack. I think what was being written here is that you can't really iterate over the priority queue. You need to create an array of that of the priority queue and sort it. Yeah, actually that's interesting. What's interesting though is this array list, it's going to be backwards, I think. If we, like if you have 1, 2, 3, 4, 5 pushed into a heap, actually no, it's fine. I think it's okay. Thinking about it, I think we're okay. Alright. Oh, we need the comparator. That's I think the last thing we need. It's just annoying how they define this. Highest CGPA is served first, so highest priority is CGPA. So we'll say if CGPA get CGPA equals b.get CGPA. We do some other things, otherwise return. Really, it's if a.get CGPA. I guess the other way around. Something like this. It's sort of a.cgpa. Here you return, so a less than b, I think is a -1, and otherwise turn a +1, and then finally continue the rest. So now inside here, any students having the same CGPA by name in ascending alphabetical order. Case sensitive alphabetical order. Okay. So ascending order means, again, A less than B. So the highest GPA though goes first. Is that what it says? Yeah, so actually you'd invert these then. You would say the other way. Highest GPA first. Now it's the other way around for the names. You're going to have the same kind of a construct here, but this time for the names. Name is less than b dot, and actually you would say it's compared to. So if a dot get name dot compare to or dot equals b dot get name, a dot get name is equal to b dot get name. Otherwise, return a dot get name compared to b dot get name. Again, this is alphabetical order. So if they're equal to each other, the names, then we have yet one more spot, one more kind of I guess logical portion, and that's going to be same CBGPA and name will be served in ascending order of the ID. So then it's similar to what we had up here, where you sort of if else with the ID. Quite involved, in my opinion. So get ID. Okay, and up here. Now, I don't know if there's like a really better way to code this, quite frankly, just all things considered. I just don't know. There might be a better way, but I don't know it. Then said ascending order or descending order? Ascending means going up, descending is going down. So yeah, so this is descending, but this one is ascending. So ascending is sort of the normal. So less than is going to give you -1, greater than gives you +1. These are sort of inverted with respect to each other, and otherwise, we assume we don't have the same IDs. So it's really else. This should be. And the last thing we need, so yeah, that's interesting. Okay, yeah, having three-way operations kind of makes it a little bit more involved, because with two-way operations you can kind of get away with certain things, but three-way operations are a little bit trickier. I think there's a way to make this more concise, but like I said, I kind of just don't know that offhand, at least not in Java anyway. I might be able to do it in other languages potentially. Name, return name, double to int. Oh, these are all ints. A mistake indeed. A mistake indeed. By the way, most software doesn't use doubles; they use floats. The things that are like intensive in terms of arithmetic precision, or I'm sorry, things that require floating point arithmetic. Often they don't need that much precision to function reasonably well, and so they don't. So it's actually a lot faster to use floats. So really, we don't have priority queues. Is this abstract? No, this is the real deal. This is a real priority queue. Cannot find symbol priority queue. Why? Class priorities. Oh, yeah, okay. Really? Why not though? Why not? Do I need to import the priority queue? That would be kind of silly. Well, we all make mistakes, right? After I just made so many mistakes, let's give the one who programmed this some slack, I think. Comparator. I forget that quite often. Specify the access privileges. Oh, it works. See if it works in general. How did we do? Probably wrong. Oh, wow. Whoa. 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 Okay. Alright. What could it be? Probably a null pointer somewhere, right? It's gotta be something. Gotta be something kind of obvious, I guess. So I guess it's probably here. If q dot is empty, I don't know, maybe it's something else. Maybe something a little more subtle. I don't know what it could be. Probably should just take the I probably should just take the. Probably should just get the test. Oh, that was it. Oh, okay. All right. Okay. Fair enough. Hey, sweet. Java data structures questions. Really? So I assume that they wouldn't do that. That they would not serve things that are not there. Just like arbitrarily, basically try to pop the heap when it doesn't have anything in it. But it didn't say anywhere that they wouldn't do that. So I actually said that when I was coding that too. I made that assumption. I said, yeah, let's assume that doesn't happen. And the inputs are okay. It's not going to try to pop something that's not there. But okay. Actually, all of those test cases tried that. So that's kind of interesting. All right, sweet. So we got another 7% there. Nice. Nice. How much more do we have? Well, we have 10 more challenges, 15 more challenges. And that's still quite a bit. Got a ways to go here. That's like 25%, but we're making headway. A little less than 25%. Yeah. All right. I think I'm gonna take a break. We spent a couple hours. I'm kind of tired. I was tired to begin with, and then I also. I don't know, man. I guess there's so much. I'm so upset. I'm just so upset. Life is hard. Life is hard. I'm upset. Life is hard, and tired. I want to take a break for maybe a few minutes. Maybe do like another hour before bed. Yeah, I feel like I'm not getting a lot of time, a lot of practice in here, which is okay. I get. Well, I don't know. I mean. Like I should be able to get through problems really quickly, you know. Like we did, I don't know how many problems we did today, but that was only 2 hours, so we did quite a few, I think, at least like 3 or 4, which is not too bad. I don't know what to say. I guess I'll say thank you for watching. I will talk to you soon. I'm gonna go ahead and take a break. And just kind of hang out for a bit. Yeah, that's it. Yeah, take a break, hang out for a bit. I'll just go with that. Just keep it simple. All right, thank you for watching. Take care. I'm gonna look to be back in like an hour or so or something. Just take a break and come back and program a bit. All right.